All right, so again, we start out by graphing the points. So A is at -1, -2. Try again. Good enough. B, so that's A. B is at -2, 0. And C is at 2, 3. Okay? And it doesn't hurt to have some sort of an ID card or something to make nice straight lines. We don't want things sloppy all over the place. It's hard to see what's going on. I do have an advantage with a smart board a little bit. I can draw nice straight lines sometimes. Okay? And now translation is 2, -1. So every point goes over 2, down 1. So C prime, try again. There we go, C primed, over 2, down 1. There's A primed. Okay, over 2. I messed up my thing a little bit, but yeah, over 2, down 1, B prime, there we go. Okay, so we label, and again, we draw as straight a line as we can. And that's it. Where people lose points on these types of problems tends to be on improper labeling or not labeling and graphing the wrong point or going backwards. I've seen that a couple times too, but that's pretty unusual. Again, same 3 points, -2, 1, A, B, C. For our initial shape. Oops. There we go. This time, how are we moving it? Everything's going what direction? Left 3, up and down, none. So every point's just left 3. So C primed right there. B primed left 3 right there. A primed left 3. Sorry. Not that one. Try again. I can draw on a transform shape. And again, the reason why you want to draw carefully is because you want to be able to, your picture is your error check. If the copy doesn't look like the original shape, you've made a mistake. And for a translation like this, it should look exactly the same, just slid around somewhere, just moved. It shouldn't be bigger, shouldn't be smaller, it should be exactly the same. If your shape winds up looking a little different, you know you've made a mistake. Recount your squares. Again, you will be getting, if you need them, the sheets with the equation, with the formulas on it for rotation and stuff like that. That will be given to you during the test for you to use if you need it. So you don't have to have those formulas memorized. Reflections, reflecting the y-axis. Again, this is one of the big things that it's pretty easy. You just have to be careful and make sure you're doing where it says. When we did this on the quiz, when we reflected, y-axis, notice it's labeled y. A lot of people reflected it in the x-axis instead of the y-axis. That was the most common mistake. So again, when we're reflecting, all we're doing is we're flipping it over our mirror. So there's my mirror. So A primed is going to be right there. D primed is going to, it's 7, so 7, right about there. B primed is 4, 4, so -4, 4. And C primed there. So again, we graph our points, label them, and then connect the dots. And look, do I have a mirror image? And we do. X equals -1. be careful with this. I have a lot of people who are doing this. When I saw in practice and people were working on this in class yesterday, I saw a lot of people doing that in the x-axis instead of the line x equals -1. X equals -1. Where does x equal -1? X equals -1 right there, according to the picture that we have in the scale that's drawn on here, because this is the x-axis. X equals -1 is right there, so that is a vertical line. Not perfect, but we get the idea. And then we just simply reflect each point over that vertical line. So V is 1, 2, 3 boxes over, so 1, 2, 3. There's V primed. R is 1, 2 boxes, so 1, 2. And now, granted, we're in the middle of the boxes, so we're a little bit approximate. T is 1, 2, 3, 4, so 1, 2, 3. There's T primed. And S primed is 1, 2, 3.5, so there's my half. 1, 2, 3.5, there's S primed. And we connect our dots. It's pretty easy to do as long as we're careful, one point at a time. Connect the dots when you're done. Identify the line symmetry, if any, in a word. Is there any line symmetry in this word? Where? Vertical down the O. Yep. Ooh. Again, that's an orientation issue right there. There we go. Okay. There we are. Rotate JKLM 270 degrees counterclockwise and note the new coordinates. Okay, so here we're going to have to rotate and write out what my new coordinates are. So in a case like this, we could rotate and then write the coordinates, or do the coordinates and then rotate using the rule. I'm just going to list the original coordinates here just so we have them. J, the original J, is at -3, -3. K is at 7, -3. L is at 6, -2, 4, 6, 7, 6, -7. And M is at -2, -7. Now, it might be easiest, now that I know the coordinates, to use my coordinate rule. And if I look for 270-degree counterclockwise rotation, because that's the one that's given here, it says AB to B -A is my rule. Okay, that's my rule for my rotation. So that means my B is going, whatever my B was before, my Y coordinate is going to become my X coordinate, and my X coordinate is going to become my Y coordinate with a change sign. So the -3 that was X, or that was Y, comes to -3 for the X. This -3 becomes a -3 for the X. This -7 becomes a -7 for the X. This -7 becomes a -7 for the X. So I got my X coordinates flipped over. Okay. -A for the Y coordinate, so the opposite of that. So that's going to be a +3, -7, -6, +2. So using the coordinate rules, I can very quickly find those coordinates, and I just plot those points. J primed is at -3, 3. K primed is at -3, -7. -3, -7. -7. There's there. Oops. L primed is at -7, -6. And M primed is at -7, 2. Right there. And that's my 270-degree counterclockwise rotation. Does that look right? Is it? Okay. Yeah, it'd be 90 degrees clockwise. Yeah, that's right. And we can kind of check it by looking at our picture again. 270 counterclockwise, same as 90 clockwise, yeah. Smartboard gives me an easy check. Okay. So there we go. Rotational symmetry. Not line symmetry, but rotational symmetry. There's line symmetry here too, all sorts of it. What's the rotational symmetry? How many times does the pattern repeat? 4 times. So how many degrees of every repetition? 90 degrees. Because it's 360 divided by the number of repetitions. Okay? Think about it. Okay? At 90, it's the same x. 90, same x. Another 90 degrees, same x. Back to 90 degrees again. Back another 90 degrees, same x. Okay? That's rotational symmetry. Take the number of 360 divided by the number of repetitions in the rotation. True or false, the composition of rotation or reflection will result in a congruence transformation, and a composition of a translation followed by reflection, then a dilation will result in a congruence transformation. What does it mean to be a congruence transformation? What does that mean? Which operations are congruent transformations, also known as isometries? What are our 4 transformations? Somebody tell me one type of transformation we have. Should be able to figure it out by the questions. What's one kind of transformation? Rotation. Rotation's one of them. Does that give me congruent objects when we're done? Yes. Reflection. Reflection. Does reflection give me congruent objects when it's done? Yes. What's another one? Translation. Does translation give me congruent objects when it's done? Yes. Dilation is the 4th one. Does dilation give me congruent objects when we're done? No, it gives me similar objects, right? But not congruent because they're bigger or smaller. So, anything that involves any of my transformations other than dilation is going to be a congruence transformation, right? As long as dilation's not involved, we're going to get something congruent out. So, number 8 is a true, because rotation and reflection are not dilation. Those are both congruence transformations. We'll be fine. We'll get a congruent figure when we're done. Number 8 has a translation, which is congruence, followed by a reflection, which is congruence, and then followed by a dilation. Oh. So as soon as I dilated it, did I keep congruence? No. I have similarity, but I don't have congruence. And again, the one thing I just want to point out with the similarity thing, you know, let's just pick a triangle here. Okay. There's a random triangle. Okay. I'm going to clone it. So I get one that's exactly like it, but I'm going to dilate it. So they're similar because they've got basically the same angles, and we can see that really easily on the smartboard. See, that top angle is exactly the same, isn't it? And that angle over here is exactly the same. This angle over here is exactly the same. So they have the same angles. They're similar, but one's bigger than the other. So the angles didn't change size, did they? When I enlarge and reduce something, do the angles change measurement? No, the angles stay the same. But the sides get bigger and smaller. That's the idea of similarity. Similar figures are things that have congruent angles but different length sides. We're going to spend a whole chapter talking about that eventually. But it's a pretty important concept. Congruent figures, all the angles and all the sides are congruent. Similar, all the angles are still congruent, but the sides are different. And again, it's really visual. Once you see that, you're like, oh, yeah, the angles didn't change size. When I enlarge something or reduce it, the angles don't change, but the sides do. And then we have that scale factor between the sides that tells me how much at K. Like I said, we're going to see all that again when we get to the chapter on similarity. So keep that kind of in your hip pocket. Something you want to hold on to. All right, graph triangle JKL with J at 4, 4. 9 was false because of that dilation. 8 was true. Okay, so J is at 4, 4. K is at negative 4, 0. And L is at 0, negative 4. Okay, so there is my lovely shape. It says perform a dilation indicated and then graph the solution for J K prime L prime with K as 1/4. What does that K 1/4 do? Is it going to be a shrink or is it going to be an enlargement? Shrink, okay? If it's less than 1, it's going to be a shrink. If it's greater than 1, it's going to be an enlargement. Okay? And guess what? All those numbers in there are multiples of 4, so it's going to divide evenly, right? Because 1/4 of 4, J prime is going to be where? At 1/4 times 4, which is 1, 1. K prime is going to be at 0, negative 1. Because negative 1, 0, sorry. 1/4 of negative 4 is negative 1. And L prime is going to be down here. And again, we draw it, we label it carefully, and we graph it, and we should see something that looks very similar, just smaller. And again, all we did was take 1/4 times every value here. Every value got multiplied by 1/4. And multiplying by 1/4 is the same as dividing by 4. Either way, you should have a calculator that could handle it. If you can't do 4 times 1/4 and know what the solution is, your calculator should be able to do that for you. I hope you can do 4 times 1/4 and come up with that solution. Even the people who don't like fractions should be able to do that. Okay. Same shape, this time we're dilating by 2. Have you noticed, by the way, that it kind of works out that things fit on the graph nicely? Hopefully it's going to work that way again tomorrow. Okay, so there's the same original shape. So that's kind of nice. Hopefully you get it right the first time because, and I'll be honest with you, if you were to graph the shape wrong, yeah, there'd be a small deduction for graphing it wrong. But if you dilated your incorrectly graphed shape correctly, the main purpose of this question is dilation. So like even if you accidentally wound up putting point J at 4, 0 or something like that, but then you dilated that shape correctly, I'd still give you most of the points because the main focus of the question is dilation, not graphing. But K equals 2 is going to put J prime to where? What's the coordinate going to be for J prime now? With K equals 2. 8, 8. Okay. Where's K prime going to be? And we're labeling it with the appropriate letters, and L primed is, okay. It's hard to screw this up. Ooh, that wasn't a good line. It's hard to screw this up as long as you label things properly and look at your picture when you're done to make sure it looks good. Describe the transformation. Okay. First thing you want to do if you're going to, before you start these problems is you need to look at the picture and decide, is it enlarged or reduced? Because if it is, you know it's a dilation. If it's not enlarged or reduced, dilation is out the window. It's the same size, you know it's a reflection, a translation, or a rotation. And you look, does it look reflected? You should have a sense at this point, looking at the pictures, if you've been drawing these and doing these homework, you have a pretty good sense quickly that this is what? It's clearly reflected, isn't it? Where is it reflected? Well, right here, right here. Okay. And you want to know what? Let's say you're having trouble with coming up with the x equals 2. If you could at least draw in the correct line of reflection for me, you're going to get at least partial credit on that, okay? You got to identify it by name. Okay? You have to tell me what it is. You can't just draw on the line. You should be able to tell me what the name of that transformation is. And ideally also tell me that it's at x equals 2 or the x-axis or y-axis or whatever. But I would also recommend drawing it in, just in case you were to make a mistake in the x equals 2. But if I can see you know where the line of reflection is, that makes a big difference. Okay? Again, that's indicating to me that you understand where it's reflecting. What is this one? It's a rotation. But you're going to have to describe exactly how much and in what direction. Now, okay,
which one does it start with? The red one?
no, it starts with the black one. Oh. Notice that the L, D, notice the letters, N, L, D. N primed, L primed, D primed. Okay? So which one's the original, the black or the red? Black is the original here, isn't it? And we're going to have color on the quiz, so that's not going to help us. So you got to look to see by the letters. They tell you which is the original, which is the copy. It's 90-degree rotation. Sorry? 90 degrees counterclockwise. CCW is good for counterclockwise. It's a big word to write. Clockwise can just be CW. Counterclockwise is CCW. If you don't indicate a direction, I will assume counterclockwise also, because that's standard. Okay, so if you just said rotation 90 degrees, I would accept that because counterclockwise is assumed. Do the two images. First, translate 3, 1. So we're going to draw that. So that's right 3 up 1. So 1, 2, 3 up 1. There's Z primed. A primed is going to be there. And I primed is going to be right there. So we do them in order. And then dilation with a scale factor of 2. So dilation, I primed was at 1, -1, so I double primed will be at 2, -2. A primed is at 1, -3, so A double primed is going to be at 2, -6. So we're a little bit off the scale here. And Z double primed is at 0, -3, so 0, -6.
Why'd you do it again? Make it bigger.
Yeah, because it was originally drawn in a particular way. We have to. The scale was preset because the original big picture was there. So again, this first I should just be I primed. I'm sorry. Just be I primed. There we go. So again, the first one gets the prime, the second one gets the double primed. We do them in order. Last one, rotation 180, reflection across y-axis. This rotation I'm going to do visual. Okay. So rotation 180. If I rotate 180, let's see. The G winds up at 2, 0. The R primed is at 4, -2. And the U primed is at -1, -3. Okay. So I'm doing that one visual. You can do it by coordinates rules as well. That's fine. I just want to do one each way, demonstrated in the review. Okay. Plot those points. G primed, R primed 4, -2. U primed is -1, -3. Grew. Despicable me. It's grew. Okay, then reflect it across the y-axis. So U double primed is going to, y-axis is this one here. Again, we're reflecting the image. So U double primed is there. R double primed is all over here. G double primed is actually right there at the original G spot. The location for point G. Okay. And there we go. Again, these transformations, one point at a time, one thing at a time, label what you're doing, be very clear in what you're communicating as you're doing it, and you'll be fine. And we got the whole review in before the bell. Yay! So I will post this onto Schoology and YouTube. That'll be my next task. And I'll get the notes out there so you can study this tonight. Again, don't just leave this alone until tomorrow morning now. Study. That means go over the review again. That means if there's homework that you did not get done, go back and do some of it. That's good practice. And if you get that done, show it to me tomorrow so I will still get it in the points if it's done before the test. So if there are assignments I didn't get checked in today and you do them tonight, you can still turn them in for points as long as you turn them in before the test is over. Okay? All right.